In this lab, we're going to experiment with density. We're going to measure the mass and volume of different materials and see how they change and see how they're related to each other. In this part of the lab, we're going to experimentally determine the density of water. So here we have a clean, dry 100 milliliter graduated cylinder, right, which is basically a glass tube that has volume markings on it. We're going to get the initial mass of this cylinder to start off. So here we have our mass balance. I've tiered it, basically setting this. I've sort of zeroed the mass that I'm starting off with. And so let's go ahead and add our graduated cylinder in there. Okay, so please make a note of that initial mass and go. And now we're going to add about 20 to 25 milliliters of water to this and measure the take those mass measurements again. All right, so I'm going to add somewhere between 20 and 25 mils. I'm just going to pour some distilled water in. All right, there we go. That's above 20. So let those bubbles over there disappear. Now we want to measure our volume very carefully. So we want to look at this at eye level. Okay, and we want to read that lower meniscus. That's the bottom of that curve, right? So let's move in over there. So hopefully you should be able to get that volume reading by looking at the bottom of that curve and see which marking it's touching. So if you're having trouble seeing it, this longer mark over here is 20, and then of course the smaller marks are each a milliliter. All right, so now let's get the mass of our graduated cylinder. So again, I make sure my starting mass there is 0. I'm going to add my graduated cylinder to the pan of my mass balance and give that a chance to settle down. Okay, and there we have our mass of our graduated cylinder and water contained in it. So of course, if you subtract the mass of the empty graduated cylinder, you'll have the mass of just the water. In case it was difficult to see that previous volume reading, I've added a piece of black cardstock behind it. So once this focuses a little bit, there we go. So read that at kind of at eye level there. All right, so hopefully you should be able to see that lower meniscus of our water level a bit better, and you can see which volume marking it lines up with. All right, so next we've got to add another 20 to 25 milliliters to this. So I'm aiming somewhere between 40 or 45 milliliters of water. So let me go ahead and add that up. All right, that's plenty. All right, give that a chance to settle, and we'll get our new volume marking. And I'll hold a piece of black cardstock behind that so it's a little bit easier to see. There's a few bubbles in there. Let's try and get rid of those. There we go. Hopefully. Okay. Yeah, hopefully those tiny bubbles won't make too much of a difference there. All right, so hopefully our bubbles are mostly settled out here. We've got a few of them. I'm going to put a bit of black cardstock here to make this a little bit easier to see. And hopefully you should be able to figure out or be able to read what the volume marking is. Oops, hopefully I can get that in focus. There we go. All right. In this case, it's okay that there is, if you're in between two volume markings, it's okay to go to the first decimal place. So for example, if you're reading this as in between 46 and 47, it's okay to say that that's 46 and a half. All right, so next up, we've got to get our mass. Do that. So again, make sure that this is zeroed. Let's add our graduated cylinder to our mass balance. Let that settle down. And there we go. There's our mass of our new sample of water, our second water reading with the graduated cylinder that it's in. So again, don't forget to subtract the mass of the plain, dry graduated cylinder. All right, finally, we want to add another 20 to 25 milliliters of this. So considering we're somewhere in the ballpark of 45, let's aim for, somewhere around 65 or 70. So let's go ahead and pour some distilled water there. All right, that's probably good. All right, so let those bubbles settle down a little bit. I'm going to add our black cardstock here to make this a little bit easier to read, hopefully. Okay, so go ahead and see if you can, once this focuses, there we go. All right, so go ahead and make that reading accordingly. All right, and again, if you feel that that lower meniscus is in between two volume markings, it's okay to go to a decimal place and say kind of 0.5 as your volume there. All right, so in this case, if it's between 68 and 69, it's okay to say 68 and a half. Though, again, if you feel that it's closer to one of those, feel free to say that. All right, and for our final mass reading, we're going to take our graduated cylinder. Again, note that we have tiered the balance, so it's starting at 0. We're going to add our graduated cylinder with our large amount of water on there. And there's our final mass reading. So please make a note of that. And of course, as always, subtract your dry graduated cylinder's mass from that to get the mass of just the water. The final step in this part of the lab is to check what temperature we're doing this at, because again, the density of water actually changes with temperature. So I've gone ahead and inserted a thermometer into our graduated cylinder of water. I've given it a chance to hopefully settle down. And so now you could read that and see what temperature we're doing this lab at. Okay, so it's pretty standard temperature, pretty normal room temperature with the air conditioning going. So yeah, here you go. In this part of the lab, we're going to calculate the density of aluminium, or aluminum as it's known in American English. Now, your directions say to use pellets of aluminium, and we have those, but I find that they sometimes collect air bubbles as they're falling in. It's kind of hard to get rid of them, and this affects our density calculations quite a bit. So instead of using pellets as the directions suggest, I'm actually going to use this little cylinder of solid aluminium. All right, so getting the mass of this is going to be a lot simpler than it is in the directions because we don't need to put this into a beaker. It's pretty straightforward to just put on our mass balance by itself. So let's do that. All right, so again, let's make sure that our mass balance is tiered, it's zeroed, and so we'll slide open this door, add in our cylinder. All right, and so that's the mass of your aluminium by itself. You don't have to worry about getting the mass of an empty beaker and subtracting that mass from your beaker and pellets combined. We have just the mass of our aluminium cylinder by itself. So again, please use this mass instead of the mass of pellets. All right, now that we have the mass of our cylinder of aluminium, we now need to get its volume. To do this, we're going to measure its volume by displacement. All right, so to do that, we're going to get the initial volume reading of a sample of water in our graduate cylinder. So let's get that at eye level there. Oops, let me turn this a little bit so it's easier to read the numbers we're dealing with there. So hopefully you should be able to read what that initial volume reading is. All right. Okay, and now I'm going to add my cylinder of aluminium to this. Now, rather than dropping this metal cylinder down into my graduated cylinder, where I might accidentally crack the bottom, I'm going to very carefully tilt this and kind of slide it in down the side. So there we go. It also avoids any splashing. You can see I've got a little bit of an air bubble there, so let's let that, there we go, got rid of that air bubble. All right, so now, hopefully, we should be able to get our new volume reading. Let that focus. There we go. Okay, so hopefully you should be able to read that volume reading. Again, if it's in between two readings, it's okay to use a half a number for that, but there we go. We're now going to use the density that we just calculated to figure out the thickness of a piece of aluminum foil. Now, even though foil is relatively flat. You think of it as sort of almost two-dimensional because it's so thin. In reality, it has some thickness, right? It's just that that thickness is a very small number. So in a way, you could think of this kind of like a cuboid of some sort. All right, so if we measure the length and the width of this cuboid, we can figure out what the depth or height of our cuboid is, which is actually the thickness. So let's start off by measuring out that length and width. So I'm going to keep this ruler here next to the edge. Oops, let's put that maybe on top of the edge so it's easier to see where that lines up. Okay, so you can see I've got that lined up with the edge over here, and we can make the volume reading accordingly here. All right, so that's the volume reading in centimeters. Yeah, I know the ruler says millimeters, but that's for each of the small markings. Each of the numbers listed is in centimeters. Okay. All right, let's do the same thing now for the width. So if I put, oops, let's put that this way so it's a little bit easier to read. Oops, sorry, hopefully that'll come to focus. The light shining off the aluminum foil is throwing the contrast off a little bit there. Let's see if maybe if I bring that closer, it'll come to focus better. There we go. That's a lot better. All right, so hopefully you can see the width there in centimeters. All right, so we're also going to need to get the mass of our sample of foil in order to figure out the volume. So here's our foil. Again, we want to make sure our mass balance is tared, as it is. I'm going to fold our foil in half just to make it a little bit easier to fit on this mass balance, actually maybe a quarter. So let's do that. So I've gone ahead and folded it so it fits onto the pan, and therefore there isn't, if it's resting against the sides, that might affect the mass reading. So let's close that so no air disturbs it. And there we go. That's our mass of our sample of aluminum foil. In this part of the lab, we're going to determine the density of a particular substance, a particular metal, by looking at different cylinders of it, so different sizes of cylinder, and we're going to graph the mass versus volume data, and then use the line of best fit to figure out what the average density is. Now, the directions call for 4 different sizes of cylinder: a small, medium, large, and extra large cylinder. While we do have cylinders of metals, we do not have different sizes of them. So we're going to modify this slightly, where instead of using, 4 different types of cylinder, we're going to use 4 cylinders of the same type and just vary the number of cylinders we use for each of our measurements. Okay, so you can see here I've taken 4 of our cylinders of our unknown metal, and I've just strung them, side by side. And if we're measuring the length of this, we can treat this sort of as one big cylinder, right? Because they all have the same diameter. Okay, so when you're measuring the length of this sort of quote-unquote extra large cylinder, you're just going to put all 4 of your cylinders side by side like this and measure the length of the whole thing. All right, so we're going to treat each of these cylinders, basically, for our reading for our small cylinder, we're just going to measure the mass and the length and diameter of one of these cylinders. But when we're doing this for our medium cylinder, we're going to take 2 of the cylinders and kind of put them side by side and treat this as if it's one bigger cylinder. Likewise, for our large cylinder, we're again just going to treat 3 of these small cylinders, treat them as if they're one large cylinder. All right, so let's go measure the mass of these. All right, so let's start off with just one of these cylinders. Okay, so this is our small cylinder, so to speak. Okay, so here's our cylinder, and I'll put a ruler there so you try and get that right in the middle so you can hopefully read that. You know, you can see where the edge of the cylinder is intersecting with the ruler. Again, each of these small measurements, each of the small markings is a millimeter, right? The numbers reference a centimeter, but each of the small divisions is a millimeter, or 0.1 centimeters. If you feel that that's in between two markings, it's okay to go a further decimal place. And, you know, so for example, if you see it as between 1.2 and 1.3 centimeters, it's okay to say that it's 1.25 centimeters. All right, now let's get the length or height of this cylinder. So I guess I'll put this here so it's easier to see where that intersects. Okay, so hopefully, let's bring that a little bit closer so you can see that a little bit better, see that at eye level. Oops, hopefully it'll focus soon. There we go. Right, so you should be able to figure out the height of that cylinder. All right, now it's time to get the mass. So again, we've zeroed our scale. Let's go ahead and put our small cylinder on there. There we have our mass of our cylinder. So you should be, oops, there we go, sorry, it's settled there now. All right, so that's the mass of our cylinder, and you should be able to use that to do your density calculations. All right, so now for our quote-unquote medium-sized cylinder, we're going to combine two of these cylinders together. You can go ahead and assume that the diameter of each of these cylinders is the same. If I hold them side by side, you can kind of see that they have you know, pretty uniform diameters, so you can use the same measurement as before. I think that should be fine. That being said, you probably noticed that the heights of these aren't quite even, so we're going to measure the height of this like so. We're going to put them sort of one top the other. Let's avoid and make sure those are even there. Okay, so we have, again, avoiding kind of parallax error. If we look at that evenly, it's lined up there. And if we zoom out there, you can see that they're stacked one on top of each other. So let's go ahead and see what the combined length of our cylinder is. If this hopefully comes into focus. There we go. Okay, so there's our measurement. So if you're having trouble seeing that, I'm going to peel that away a little bit just so you can see where that reaches on our scale. All right, now we're going to get the mass of our medium cylinder, which in actuality is of course two cylinders. So once again, make sure our scale is zeroed. We're going to add our two cylinders there. And now you have, oops, give it a second to settle. There we go. There you have the mass of our medium-sized cylinder. Okay, for our large cylinder, so to speak, we're going to use 3 of these cylinders. Again, I think we can assume that the diameter is roughly uniform, but we will put these all side by side to get the our length. So let's make sure this is lined up. So if I'm looking down on that, dead on. So avoiding parallax error, it looks like that's lined up there. Oops, let's make sure that's even. Avoiding parallax error. Okay, and then I have all of these pushed together. There's my, oops, hopefully that'll focus soon. Okay, so there's my length of all 3 cylinders, or my large cylinder combined. So I'm going to peel this away just a little bit so you can see where that, there we go, so it lines up with the markings. All right, okay, so let's get the mass of our large cylinder. So of course make sure our scale is 0. We're going to grab the 3 small cylinders that make up our large cylinder, and let's put that on the pan properly there. There we go. there we go. Okay, so close that, and there's our, once it's settled down, all right, there we go. There's our mass of our large cylinder, so to speak. All right, finally we're going to combine all 4 of our small cylinders to make the extra large cylinder. So let's go ahead and put those on our scale. Okay, so let's get that even. All right, so make sure that our bottom is zeroed out there. Okay, so that's avoiding parallax error. It looks like that. Oops, it's a little bit fast. Let's push that there. There we go. That looks about even to me. Okay, so looking directly at it, avoiding parallax error, it looks like it's even. And so with all of our cylinders together, let's look at what the combined length is. Okay, so there's our length. And again, if you're having trouble seeing that, I'm just going to peel this away a little bit. You can see which marking on our scale we have there. Okay, and finally, let's get the mass of all 4 of our small cylinders making up our extra large cylinder. So notice we're tiered here. Let's grab all 4 of these cylinders and add them to our mass balance. Okay, let that settle down. Give it a second. Okay, there we go. All right, and there's our combined mass for our extra large cylinder.